Hi, welcome to Lesson 21, Session 1. Today we'll be working on multiplication as scaling. We're going to be comparing the size of a product to the size of one factor on the basis of the size of the other factor. And if that makes no sense to you, don't worry, because I think by the end of the lesson, you'll get an idea of what it is that we're going to be doing. We'll be working in our Ready Classroom math workbook on pages 425 through page 428. So if you have your Ready Classroom math workbook, go ahead and open it up, take it out, and turn to page 425. All right, so this is page 425 here, and it says this. What does scaling mean? And that's what we're going to work on today, and then we'll do a graphic organizer that talks a little bit more about scaling at the end. But let's go ahead and see what we've got here. So it says this, model it. Complete the problems below. Number 1, changing the size of a quantity by multiplication is called scaling. Stretching and shrinking are two different ways to scale a quantity. This bar here has a length of 6 units. 1, 2, 3, 4, 5, 6. So the length from here to here is 6 units. Now, using the bars, okay, so it says, now use the bars at the bottom of the page to complete parts A and B. So we're going to use these two bars here to complete parts A and B. So part A says this, circle the bar that shows the length of 6 units being doubled or stretched. Underline the bar that shows the length of 6 units being halved or shrunk. So when I think about something that that stretches, think about what happens when something stretches out. That's right, it gets longer. Now, when something shrinks, what happens when something shrinks? That's right, it gets shorter or smaller. So now, when we're thinking, I see this word doubled. Doubled usually means if you're going to double something, that means you're going to multiply it by 2. So when I think about the number 6 being doubled, if I know that I have 6 and I want to multiply 6 by 2, or I want to double it, I'm going to have 12. Which of these pictures shows me 12? That's right, the blue units show me 12. So I'm going to go ahead and circle the blue bar that shows the length of 6 units being doubled or stretched. So as you can see here, if I circle this section here, I see that these 6 units are being stretched and made longer to create these units. Now I'm going to underline the bar that shows the length of 6 units being halved or shrunk. When you talk about something being halved, that means it's being cut in half or divided by 2. So doubled means times 2. When something is halved, that means it's times a half. So I'm going to underline this second picture because I'm underlining the bar that shows the length of 6 units being halved or shrunk. Half of 6 units is 3 units. Therefore, I'm underlining this to 3 units. Now, part B goes on, and part B says, write a multiplication equation for each bar. Circle the factor that describes how the length of 6 units is being stretched or shrunk. So here, we're starting with a base of 6. So we start with a base of 6 units. Then, what are we going to multiply 6 by to get 12? That's right. We're going to multiply it by 2, meaning that the 6 is being doubled. And then the number, and then in this picture, we're going to start with 6. And what are we going to multiply this 6 by? Well, we're cutting it in half, so we're going to multiply it by a half, which means 6 times a half equals 3. Now, the second part of this was circle the factor that describes how the length of 6 units has been stretched or shrunk. So, what number here makes this this red bar stretch to the blue bar? That's right, it's the 2. Because we started with 6 and then we stretched it by multiplying it by 2. Now, which factor here shows us that we're cutting this original 6 in half or multiplying it by a half? That's right, the 1/2. All right, let's go ahead and go to the next page. Page 426. Now, I need to quickly grab a piece of paper. Now, on this page, we're going to look at this table here. Now, this table here says, use the table to make generalizations about scaling the whole number 6 through multiplication by various factors. So if you look here, when we the 2 factors are what we multiply by each other, and then they always equal the product. So this number times this number equals this number. This number times this number equals this number, and so on and so forth. So that's how we read this table. We're going to multiply the 2 factors to get the product. Now, to begin, it says, underline the products. So we're going to be looking at this product line. Underline the products less than 6. So we're going to look at all of these products and find the products that are less than 6. So I'm going to just start all the way over here. 6/10 is less than 6. It's actually less than 1. So that number is less than 6. 2 is less than 6. 3 is less than 6. Is 6 less than 6? No, 6 is equal to 6. So I can't underline that. I also can't underline that 6. 9 is more than 6. 15 is more than 6. And 18 is more than 6. So I can no longer underline any factors because I only have these 3 factors that are less than 6. Now, when we look at these, there we go. When we look at these 3 factors, what do we recognize or what do we notice about the factors in these 3 equations? Like 1/10 times 6 equals 6/10. 1/3 times 6 equals 2. 1/2 times 6 equals 3. What do we notice? What do these factors, what do the factors for these products have in common? Well, we see, first of all, that they all multiply by a factor of 6. And then if we look at these 3 factors, what do they all have in common? What's interesting about these 3 factors here? I hope that you notice that all 3 of these factors are less than 1. 1/10 is less than 1, or 1/3 is less than 1, and 1/2 is less than 1. They're all less than 1. And when we multiply any of these factors less than 1 times 6, we always get a product that is less than 6. So we notice that all of the factors are 6. They all have a factor of 6 and a number less than 1. So the factors are 6 and a number or a factor less than 1. Let's go on to part B. Part B says this: circle the products that are greater than 6. What do the factors for these products have in common? So we already know that all 3 of these factors are less than 6, so we're not going to worry about those. We're looking for factors greater. we're going to circle factors greater than. We underlined products. We're going to circle we're going to circle products greater than 6. Here we underline products less than 6. There we go. So we're looking at the products. We know these are all less than 6. Well, 6 is equal to 6, so I wouldn't say it's greater than 6. So we can't circle those two. But 9 is definitely greater than 6. 15 is greater than 6. And 18 is greater than 6. So now if we're looking at these 3 products and factors, what do the factors for these products have in common? So when we look at the factors for these products, what do they all have in common? Well, again, we see that they all have one factor that is 6. And then what do we notice about the other factors? What do all these factors have in common? That's right. All of these factors are factors greater than 1. They're all more than or greater than 1 whole. So the factors are 6 because one of the factors is always 6, just like it was over here. But instead of these being less than 1, now all the factors are a number greater than 1, greater than the number 1. Finally, we're going to put a box around the products that are equal to 6. So I see that that number is equal to 6 and that number is equal to 6. Now, when I look at these two products and factors here in the middle, I again see that we still have 2 products. 2 of the factors are 6. And then what do you notice about the 2 factors here? What do they have in common? Well, the factors are 6 and a number equal to 1. So what can you notice about using this table as an example? What are some things that you notice about when you multiply by a factor less than 1, a factor equal to 1, and a factor greater than 1? That's right. As long as this factor of 6 remains constant, anytime you multiply 6 by a factor less than 1, you'll get a product less than 1. Anytime you multiply these 6's by a factor equal to 1, you get a product of 6 or equal to 6. And then finally, anytime you multiply a factor of 6 by a factor greater than 1, you always get a resulting product that is greater than 6 or greater than the factor that you multiplied by. All right. So now if we followed that line of thinking, if we look down at number 3 says this: describe the products you get if you multiply 8 by factors less than 1. Describe the products you get if you multiply 8 by factors greater than 1. Give some examples that justify your answers. So this is what I wrote. If you multiply 8 by a factor less than 1, the product is less than 8, always. If you multiply 8 by a factor greater than 8, greater than 1, not greater than 8. I must have been tired. If you multiply 8 by a factor, I wrote that wrong both times. There we go. This is what happens when Mrs. McGuire is sleepy. I'm going to go ahead and start over at the beginning because I want to make sure I read that the right way. If you multiply 8 by a factor less than 1, the product is less than 1. If you multiply 8 by a factor greater than 1, the product is more than 8. So for example, 8 times 1/2 is less than 1, so it results in a product that is less than 8. I'm going to skip over here. When we multiply 8 by a factor greater than 1, we always result in a product greater than 8. When we multiply 8 times a factor, in this case, if we multiply 8 times 1/8, that gives us an answer of 8/8, which equals 1. So now it's interesting here. This is interesting because we're multiplying 8 times a product less than 1, but it gave us a factor of 1. But don't worry, 1 is still less than 8, so it still follows our rule. See if you can find any more examples that would prove our theory that anytime you multiply 8 by a factor less than 1, you get a product less than 8. Or if you multiply 8 by a factor greater than 1, the product is more than 8. Come up with 2 or 3 more that work, and then go ahead and so pause the video there and come up with 2 or 3 more options. And then we're going to go ahead and move on to our graphic organizer. All right, now we're going to look at multiplication as scaling. So we're going to look at this vocabulary word of scaling. What does scaling mean? Scaling means that we're resizing a quantity by multiplying, meaning we're starting with an amount, and then when we multiply it by a number greater than 1, we stretch it and make it longer. When we multiply 8 by a factor less than 1, we shrink the amount to a smaller amount or a lesser amount. So here, in this example here, 8 times 3 gives us 8 times 3, which is 24. We are stretching 8 by multiplying it by a factor greater than 1. Now over here in this example, and then I'll go to the others. In this example, we are multiplying 8 times a fourth because we are taking 8 and we're shrinking it. We're making it smaller. We're multiplying it by 1/4. So if I cut 8 in fourths, 1, 2, 3, 4, 8 times 1/4 equals 2. I've shrunk 8 and made it smaller to 2 because 1/4 is less than 1, so I'm going to get a resulting product of less than 8, the number I started with. Now, a couple more examples of scaling. Multiplying by 1 does not scale the quantity. It stays the same. So anytime you multiply a factor by 1, the number stays the same. So if you multiply 8 times 8 eighths, you're going to get a resulting product of the same answer. It's equal because 8 eighths is the same as multiplying it by 1. All right, now we're going to go ahead and look at these other 2 examples. Multiplying by 2 doubles the size of a quantity. Multiplying by 1/2 halves the size of the quantity. And with that, that is the end of our lesson for today. If you have any questions, you can always email your teacher. Otherwise, we'll see you next time. And if you're in my class, you're going to be finishing the page 427 and 428. And that will be part of your assignment for today.